Have you ever watched a concrete mixer truck sitting at a red light and noticed something strange? The truck is completely stopped, but its enormous drum keeps turning. It looks like the concrete would somehow fail if the drum stopped for even a moment. But that's not actually what's happening. The drum isn't simply mixing non-stop. It's performing a carefully controlled job designed to keep the concrete uniform until it reaches the construction site. The first thing to understand is that a mixer drum doesn't operate at one constant speed. There is a major difference between mixing concrete and agitating it during transportation. When a batch needs to be thoroughly mixed, the drum rotates much faster. The American Concrete Institute says truck mixers generally mix in the range of about 12 to 18 revolutions per minute, with a properly loaded mixer typically requiring around 70 to 100 revolutions to achieve adequate mixing. Once that process is complete, the drum doesn't need to keep spinning that fast. During transportation, ACI recommends a much slower agitation speed, typically around 2 to 4 revolutions per minute. That's why the drum can appear to be constantly moving, even when the truck is doing nothing at a traffic light. The truck isn't repeatedly making a new batch of concrete, it's maintaining the batch that is already there. The inside of the drum is where the real engineering becomes visible. Running along the interior are spiral-shaped blades, often called fins. Their job is to move the concrete as the drum rotates. During mixing and transport, the drum turns in one direction. The fins repeatedly lift and move the mixture, helping keep the cement paste, water, sand, and aggregate distributed throughout the batch. But the same mechanism can perform the opposite task. When the driver reaches the construction site and needs to discharge the concrete, the drum reverses. The fins then guide the material toward the opening at the rear of the drum, where it flows onto the chute and into the placement area. So the drum doesn't need separate machinery for mixing and unloading. Changing the direction of rotation changes what the internal blades do. That simple principle is one of the reasons the mixer truck can carry, maintain, and discharge a batch using the same rotating drum. This is where the real reason for the slow rotation becomes important. Fresh concrete is not a single uniform substance. It contains several ingredients that must remain properly distributed throughout the batch. During transportation, the mixer needs to maintain that uniformity and prevent settlement. That's what the slow rotation is mainly accomplishing. ACI specifically distinguishes agitation from full-speed mixing. After the required mixing has been completed, the organization recommends limiting additional rotation to what is necessary to prevent settlement and difficulty restarting the drum. That distinction changes the way you should look at a mixer truck. The drum isn't endlessly trying to make the concrete more mixed. It's protecting the consistency that was already achieved. And that's important because excessive rotation isn't harmless. It might seem logical that if slow rotation keeps concrete uniform, faster rotation would keep it even better. But concrete doesn't work that way. ACI warns that excessive mixing after adequate blending can reduce slump. If additional water is then added to restore the original slump, the resulting concrete can lose strength. That means the operator has to find a balance. Too little agitation can create problems with settlement and make the material harder to restart and discharge properly. Too much mixing can change the concrete's properties unnecessarily. The objective isn't maximum movement, it's controlled movement. This is why the drum has different operating ranges, instead of simply spinning at its maximum speed throughout the entire delivery. The truck is essentially managing a narrow window between keeping the mixture uniform and disturbing it more than necessary. Now the mystery becomes much easier to understand. When the truck stops at a red light, the vehicle's wheels stop, but the drum drive can continue operating independently. Modern transit mixers commonly use a hydraulic system to rotate the drum. The truck engine can drive a hydraulic pump through a power takeoff arrangement, which supplies the hydraulic motor responsible for turning the drum. That means the engine doesn't have to move the truck forward for the drum to rotate. The truck can be stationary while the hydraulic system continues turning the drum at its controlled agitation speed. Some mixer designs have also incorporated systems that automatically control drum speed based on vehicle movement. Patent documentation describes systems designed to maintain a lower, controlled drum speed during travel, rather than allowing drum speed to rise and fall unnecessarily with engine speed. So when you're watching a mixer truck sitting at a traffic light, you're seeing two separate systems doing two separate jobs. The truck is waiting. The drum is maintaining the load. Here's where the popular explanation needs correcting. The phrase, "the drum never stops," makes a great thumbnail, but it isn't literally true for every mixer, every situation, or every operating procedure. The drum can be stopped on mixer equipment, and specific operating conditions can determine what the operator should do. What matters during normal delivery is maintaining the concrete according to the manufacturer's operating instructions and applicable concrete specifications. ICI guidance makes the same principle clear. After adequate mixing, the drum should operate at an agitation speed below the full mixing range, with no more agitation than necessary. So the interesting engineering question isn't actually, why can the drum never stop? It's, why does the operator normally keep it moving? And the answer is much more practical. The drum is protecting the uniformity of a time-sensitive material. There is another reason manufacturers and engineers don't simply run the drum as fast as possible. The mixer itself experiences wear. The rotating drum contains heavy concrete that constantly moves against its internal surfaces and fins. The drive system also has to supply torque continuously. A patent describing transit mixer technology notes that drum and fin wear is significant enough to require eventual replacement, and describes constant speed control as a way to reduce unnecessary revolutions, fuel use, and mechanical wear. That reveals something most people never consider. Every unnecessary revolution isn't just movement inside the drum, it's another revolution for the machine itself. So controlled rotation isn't only about protecting the concrete. It can also reduce the mechanical workload imposed on the mixer. Some systems have therefore been developed to maintain a lower, more consistent drum speed, instead of allowing rotation to increase whenever engine speed rises. The goal is simple. Move the concrete enough. Don't move it unnecessarily. When the truck finally arrives at the construction site, the entire purpose of the drum changes. Instead of keeping the mixture moving inside the drum, the operator needs to get it out. The drum reverses direction. Those same internal fins that previously helped move the concrete away from the discharge opening now carry it toward that opening. From there, the concrete falls onto the discharge chute and is directed toward the placement area. This reversal is one of the cleverest parts of the entire machine. The mixer doesn't need a separate conveyor hidden inside the drum to push the concrete out. The geometry of the fins and the direction of rotation do the work. One drum, one set of blades, two completely different functions. And everything is controlled by the operator through the drum's drive system. A mixer truck isn't simply carrying a pile of concrete from one location to another. It's transporting fresh, unhardened concrete that must arrive in a condition suitable for its intended use. A STM specification for ready-mixed concrete specifically covers concrete manufactured and delivered in a freshly mixed and unhardened state, including concrete handled by truck mixers and truck agitators. That is why the drum is such an important part of the delivery system. The concrete plant can produce the mixture correctly, but the journey still has to preserve that condition until the material reaches the job site. Traffic lights, congestion, detours, loading delays, and other interruptions all become part of that delivery challenge. The slowly rotating drum gives the operator a way to maintain the batch during that journey without continuously subjecting it to full-speed mixing. The red light may only last a minute, but the concrete doesn't know that. So, why does the drum keep turning when the truck is stopped? Because the truck isn't trying to prevent the concrete from instantly becoming solid. It's maintaining the mixture. After the concrete has been adequately mixed, the drum normally shifts to a much slower agitation speed. The internal fins keep the ingredients distributed, while the hydraulic drive allows the drum to operate independently of the truck's forward movement. And there's an important engineering balance behind it all. Too little movement can create settlement and restarting problems. Too much movement can cause unnecessary mixing, slump loss, fuel consumption, and equipment wear. The drum, therefore, doesn't spin because it has to spin as fast as possible. It spins because controlled movement is the best way to protect the load during delivery. So the next time you see a concrete mixer truck sitting at a red light with its drum slowly turning, you're watching more than a strange-looking machine. The truck is stationary, but its cargo is still being managed. The drum has shifted from fast mixing to gentle agitation, keeping the fresh concrete uniform without unnecessarily working it. That spinning isn't about making concrete harder or softer. It's about preserving the batch until the moment those blades reverse and the concrete finally leaves the truck. Let us know in the comments. And don't forget to like, subscribe, and turn on notifications for more engineering stories behind the machines we use every day.